Hi everyone, welcome back to Tech-Bimba channel. In a previous video, we talked about what thread is and what process is. In our today's video, we will dive into how to create a thread. In Java, there are mainly two ways of creating a thread. One by extending a thread class, other is by implementing the runnable interface. Before looking into the approaches of creating a thread using these two, it is important to understand what is runnable interface and what is thread class are. Runnable interface is the interface present in a java.lang package. This interface has a one abstract method that is run. Its return type is a void, means it's not returning anything. Since this runnable interface has exactly one abstract method, from Java 8 onwards, it is marked as a functional interface. This runnable interface itself is not having any thread specific methods. Thread class is the one that implements the runnable interface. It provides the default implementation to the run method. Thread class also has a thread specific methods like a start, sleep, join, etc. So in short, runnable is a functional interface. It has a one abstract method that is run. Its return type is a void. Thread class is the one that implements the runnable interface and provides the default implementation to the run method. Now let's see how to create a thread by extending a thread class. We have created a class with the name myThread. It is extending a thread class. We have overridden a run method here. Within this, we can provide the logic or a part of the code we want to run as a part of the new thread. So here we are having a system.out.println. We are printing this line and we are capturing the name of the thread that is actually running this line of a code. This is our main thread. Here we are having a public static void main method. So here we are creating the instance of our custom thread class. We are setting the thread name as a mythread1. Then on line number 13, we are calling the start method. Let's execute this, then we can see this program line by line. So on executing this one, Java virtual machine instance will be created, one process will be allocated. Just in time, compiler figures out what is the starting point of the program. In our case, it is public static void main. So at that time, one thread will be created by the JVM itself. That thread is nothing but a main thread. That's why line number 7, if you note on the console what it has printed is log thread. So main has started the application. Main is nothing but a name of the thread. Okay. So then what we are doing here is we are creating the instance of the class. Then we are setting the name to the thread. Okay. So here we are having a one more print statement. Okay. Has created the instance of the custom thread class. We got this as well. Even though we have created the instance of a thread here itself, yet thread is not started. When we call a start method, at this time, mythread1 is ready to execute this part of a code. But now, here, thread scheduler is the one that decide which thread to be executed. So at this point, we are having a mythread1 and a currently executing thread, that is main. So thread scheduler is the one that decide either mythread1 has to be executed or either main thread has to be executed. So in our case, if you notice, main thread continues to execute, and we can notice here thread main is about to sleep. We got this line. On line number 15, we are having a thread.sleep 1000. This sleep method is present in a thread class, so it's a static method, and we are passing a number here 1000. So what it does is it interrupts the current execution thread for a 1 second. So 1000 millisecond we have provided, so thread will be interrupted for a 1 second, means at that time CPU will be idle. Now to utilize the CPU cycle, thread scheduler has given a chance to execute my thread 1. Okay, so now my thread 1 basically executes the CPU cycle, and we can see this line of the code. Okay, this line is executed. Okay, so this line is coming from our run method. Once whatever the code we are having inside the run is executed and 1 second is elapsed, right? Again CPU scheduler basically ask main thread to continue its execution, right? That is the reason we can see here thread name as a main here, and we can see 1 second elapsed. At the end this line of the code will be executed, so we can see thread main has reached the end of the main method. So this is how the execution of a thread works actually. So this is how we can create a thread by extending a thread class. Now let's see this one by commenting out this thread sleep part. Okay, if you comment this out and execute, let's see what will be the output. So we got this line. Okay, then has created the instance of the custom thread class, so we got this line too. So at the line number 13 we are having a my thread dot start. At this point write my thread 1 and a main thread, we are having a 2 threads. Okay, now it's up to thread scheduler, so it can ask my thread 1 to basically ask it to complete the code, or it might ask main thread itself to continue its execution. In our case main thread got a chance. That is the reason we can see this line of the code is executed. So once it finished its execution, right, CPU scheduler or a thread scheduler has given a chance to my thread 1. So once my thread 1 gets its chance, we can see whatever we are having inside the run method, right, that will be executed. So this is how we can create a thread by extending a thread class. Now let's see how to create a thread by implementing the Runnable interface. Here we are having a class with the name my Runnable thread. We are implementing a Runnable interface. We have overridden the method run here, and we want to execute this line of the code as a part of a new thread. So we are having a main class here. Inside this one we are having a public static void main. We are creating the instance of our custom class here. Then at the line number 10 we are creating the instance of a thread class, and we are passing a Runnable as a constructor argument to this thread class. At the line number 11 we are setting the name of the thread. So at the line number 12, right, thread dot start, so we are asking my Runnable thread to execute, right, at this point. So line number 13 having a thread dot sleep, so we are asking current thread to be interrupted for a 1 second. So at the line number 14 is the last line in the main method. Okay, so once we execute, we can see this line got printed here. So here thread is main. So once we start this one, even though main thread got its chance to execute, since we are having a thread dot sleep, right, it got interrupted for a 1 second. At that time, to utilize the CPU cycle, my Runnable thread 1 utilizing the CPU cycle, and it's running, because of which we can say able to see this line of a code is printed on the console, right? Once a time is elapsed, and then again the main thread will wake up and it will finish its execution. So this is how we can create a thread by implementing the Runnable interface. So if you note here, we are passing the runnable object as a constructor argument to a thread class here. Okay, since runnable is a functional interface, which means it has exactly only one abstract method, so we can leverage that, and instead of providing a runnable object instance here, right, we can provide a lambda expression as a constructor argument here. So what I mean here is, so inside a thread constructor, we can directly provide the implementation of a run method. So this is possible because runnable interface is a functional interface. It means it has exactly one abstract method. Okay, so because of which we can directly provide the lambda expression like this. So with this, we can avoid creating a new class, and it's not required to override the run method. So all this can be done within a single line. Okay, so let me execute this one. Okay, so once we execute this line of the code is printed here. Okay, so here we are creating the instance of a thread. Once we do thread.start, right, at this time new thread is created and it is ready to execute this part of the code. Since we are having a thread.sleep 1000, right, even though we started, it's up to the thread scheduler, right? It might execute the new thread or it might continue with the existing main thread. So say suppose it has picked the main thread, but since in a main thread we are having a thread.sleep for 1000 millisecond, so here at this point main thread interrupted. So to utilize the CPU cycle, so whatever the new thread we have created, right, that will be executed by CPU. So that's where we can see running in, and we got the name of the thread as a thread 0. Note here, this thread.0 is assigned as the name to our thread. So since here we have not set the name, thread itself has given one name to our thread. That is the reason we got it as a thread 0. Once this part of the code is executed and once this time is elapsed, right, then again main thread wakes up and it will continue its execution. This is how we can create a thread using a lambda expression. Okay, hope this is clear to you guys, how we can create a thread by extending a thread class, then by implementing the runnable interface, then by using a lambda expression. Now follow-up intro question is, which approach is better? So in case of creating a thread by extending a thread, right, one limitation is Java won't support a multiple inheritance. Since we are already extending one class, that is thread, we are not allowed to extend any other class. Whereas in case of a runnable interface, we can extend one class. Considering this flexibility, so we can say that runnable is better choice for creating a threads. So other aspect is, in case of a runnable, we are segregating what to execute and how to execute. What I mean here is, whatever the code we want to execute as a task, right, we can provide its implementation within the run method. Then we pass that runnable object as a constructor argument to a thread. Means this runnable is having a code what to execute, and how to execute is responsibility of this thread framework that is present in the java.lang, right? So here we are cleanly segregating what to execute and how to execute. So it is a cleaner and a neater approach. Whereas in case of creating a thread by extending a thread class, right, we are making our custom thread as a child of our thread class, which means, right, in a main class, if you see here, we are creating the instance of our custom class. On top of itself, we are calling the start method. Means my thread is nothing but a child of a thread class. Here we are not segregating what to execute and how to execute. Both are in the same class, right? In a sense that they are in the same class. So considering this design approach as well, creating a thread using a runnable interface is a better choice. Now the next question is whether to use a Runnable or a Lambda. Okay, in case, right, we are having a very limited amount of the code that we want to run as a part of a separate thread, then it is better to use a Lambda expression. In case we are having a logic that is very complicated and it has a huge number of lines, right, in that case we can go for having a separate class, then mentioning it with a implementation of a Runnable, right? So that in that case we can go ahead with a Runnable. Okay, so hope this is clear when to choose which way for creating a threads. Okay, so that's it for the today's video. If you found this video helpful, please like, share and subscribe to the channel. In the next video we will dive into how thread lifecycle works. See you in the next video. Thanks for watching.